All right, let's get started with the work. Number one says y is equal to x squared minus x minus 6, and it wants us to graph to solve the answer, right? And remember, our solutions are going to be our x-intercepts. So we're looking at number one, and it says to graph. The easiest way for me to do this is to be able to have a list of table points to plot on that graph. So what I would do if I were you is I would plot that in my calculator, x squared minus x minus 6, and I would go second table. Now, if you see, we have a graph that goes from -6 to +6 in both directions, right? So we have from -6, so 1, 2, 3, 4, 5, 6, to +6, 1, 2, 3, 4, 5, 6, and the same for our y-axis. 2, 3, 4, 5, 6. Yeah. All right. So I'm going to ignore all the ones outside of the -6, +6 range. As soon as I encounter something that says, I don't know, like -4 says 14 next to it, I'm not going to worry about that point. But -3 says +6. So if I go -3 on the x-axis, 1, 2, 3, that's going to give me a +6 on the y-axis, which is all the way up at the top. The next one says -2, 0. I know where that is right there. And that's going to be an important point. Why? Because it's where it crosses our x-axis, right? And then we have -1, -4. So -1, -1, 2, 3, 4. This isn't exact, but it's okay. And then we have 0, -6. 0, -6. We also have 1, -6. So what does that tell us about this parabola? That tells us that this parabola's vertex is not on a pretty point. It tells us that this parabola's vertex is actually in between these two numbers when x is 0.5. Because we have these matching numbers right here, we know that the vertex occurs between them. Remember, there's symmetry, the axis of symmetry, right? All that good stuff. 2 is going to be -4. So see all these matching points. 3, 0, and 4, +6. So this is our fancy schmancy parabola. Try to connect those dots as best you can. Don't forget to put arrows. But these are the 2 points we're actually talking about. So what are our solutions? Our solutions are when x is equal to -2 and when x is equal to +3. We could say it like that. We could even say it like this. We could say it a number of ways. Okay, we could say them individually, x equals -2 and x equals +3. You could say them a number of ways. Whenever we're talking about graphs, usually we're looking for points, so I would suggest doing them this way. All right, number 2 says very much the same thing, except our equation says -2x squared minus 14x equals 20. Well, we know from past experience that we can't do that yet. Okay, we can't do anything with that yet. We can move everything over to one side. We can do that. So I can subtract 20 from both sides, and I'll get -2x squared minus 14x minus 20 is equal to 0. Now I can graph that. Remember, we can just substitute in a y for that 0, and it makes a little more sense whenever we're graphing. Another thing I can do is I can reduce this. I can reduce that. And the only reason I'm suggesting you do that is for practice later on. And I hope you recognize that each of these numbers are even, so we can reduce each of these values by 2. So I could even get rid of that negative. I could do a lot of things to this. However, I can also type this into y equals exactly how it is. So go back to y equals, clear out that first one. I'm going to type in -2x squared minus 14x minus 20. Instead of hitting graph, I'm going to hit table again. If you look at our graph, everything is within +6 and -6, so we're ignoring a lot of this graph. All right? We have +6, we have -6 on each side. So let's draw that out real quick. The first point I see is at negative 5, 0. So 1, 2, 3, 4, 5, 0. The next point I see is at negative 4, positive 4. So 1, 2, 3, 4 over. The next point I see is at negative 3, positive 4. Negative 3, positive 4. Then the next point I see is at negative 2, 0. I can't fit any more points on this graph because it goes to negative 8 right there in the y-axis. So just do the best with what I have and draw the parabola. Make sure you put arrows at the end. And once again, we don't have our vertex as a point. We know that it does occur in between negative, 3 and negative 4. We know it's going to occur between there at negative 3.5. But that's not what we're really looking for. We're looking for these 2 points right here, which once again, we could say x equals negative 5 and x equals negative 2, or because it's a graph, we could say negative 5, 0 and negative 2, 0. All right, moving on. Number 3. Number 3 says solve the following equations by factoring. Solve the following equations by factoring. All right, let's do this. So number 3 says negative 16t squared equals negative 36t plus 8. We need everything on the right-hand side. We don't like negative values, so I'm going to move this guy over, and I'm going to get 0. Well, first, I'm going to add 16t squared to both sides. And I'm going to get 0 equals 16t squared minus 36t plus 8. Now I say to myself, is this in the least common factor, right? Is there a greatest common factor that I can withdraw from each of these? And the answer is yes. Yes, I can. Each of these are divisible by 4. So I'll take out a 4 from everything. And I'll end up with 4t squared minus 9t plus 2. All right. Now I'm going to do the A, C method, all that stuff, right? So A times C gives me 8. And I'm going to list all the factors of 8. You remember, if this is positive, then either both of these factors should be positive or both should be negative. And the B, remember this is ax squared plus bx plus c. The B tells me what the big side needs to be. I know that my big side is all going to be negative, so I know that my little side also has to be negative, because a negative times a negative gives me a positive. All right, so let's list all the factors of 8. We have 1 and 8, and we have 2 and 4, and I think we're done. So which one is going to give us negative 9? That's negative 1 and negative 8. So now we rewrite our equation, but instead of negative 9t, we're going to write negative 1t and negative 8t. So we get 4t squared minus 1t minus 8t plus 2. And this works because negative 1t minus 8t is still negative 9t. Now we're going to group them. And remember, this number gets its sign attached with it. And we hate negative front values. So what are we going to take out of this? What is the greatest common factor of 4t squared minus 1t? Well, my greatest common factor is at least t. Anything else? No. And we're going to end up with 4t minus 1 after I take out a t from each of these. Now, what can I pull from this one? I can definitely pull a negative because my front number is negative, and I don't like that. I can also pull out a 2 because both of these are even. So I'm going to pull out a negative 2 from each of these. If I divide negative 8 by negative 2, I'm going to end up with 4, and then the t falls with it. If I divide positive 2 by negative 2, then I'm going to end up with a negative 1. Do you see how we got the same values here? That's our checking mechanism, and it tells us that we did it correctly. What are the factors, though? This is one of them. And then this, the GCF of that quadrinomial? Anyway, the 4-termed value, what we took out of it is t minus 2. That will be our second factor. So we have 4t minus 1 and t minus 2. Now, notice the instructions say solve. We don't stop until we have the values. So now we're going to use the zero product property to say 4t minus 1 is equal to 0, and t minus 2 is also equal to 0. We're going to add 2 to both sides on this one and get t is equal to 2. We're going to add 1 to both sides here and get 4t equals 1. Divide by 4, and I'll get t is equal to 1/4. So these are my two answers. T is equal to 1/4 and t is equal to positive 2. That's how you solve it by factoring. If you have any questions, please make sure you ask in the comment section. I'll do my best to explain as much of this as possible. Okay? It's a lot of steps going on, and it's a lot to forget, but just focus on what you can do. All right. I'm going to run through this next one, see if we can get it done before my time runs up. I'm on a 15-minute timer per video. So I get 121x squared plus 27 is equal to 108. I need everything on the same side, so I'm going to subtract 108 on both sides. I'm going to do 27 minus 108, and I'm going to get negative 81. 121x squared minus 81 equals 0. Your alarm should be buzzing, like loud, okay? This is a perfect square, 121, it's 11 times 11. This is a perfect square, 81 is 9 times 9. There's a difference in between. It's a binomial. Do you remember all these questions? Is it a binomial? Is it a difference? Are numbers perfect squares, and do we have even powers? Yes, 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 and yes. And yes. So I'm going to do the square root of each term, and I'm going to put 1 in one section, 1 in the other section. There's going to be a plus sign in one and a minus sign in the other. Do you remember doing all this? So the square root of 121 is 11. The square root of x squared is x. I'm going to put 11x in the front of each of these. The square root of 81 is 9. So I'm going to put in a positive 9 and a negative 9. Do you see that? Now, I'm going to use the zero product property again. I have 11x plus 9 equals 0, and 11x minus 9 equals 0. On this one, I'm going to subtract 9 on both sides. On this one, I'm going to add 9 on both sides. I'm going to get 11x is equal to negative 9, and 11x is equal to positive 9. I'm going to divide by 11 on both sides of both problems. And I'm going to get x is equal to negative 9 elevenths, and x is equal to positive 9 elevenths. That's my two answers. I have x by itself with a value. That is the solution. Right? I'm going to continue on with another video, but I'm going to stop here because I don't have enough time to cover another problem.